Okay. Two more with that. X bar is 4.7. Sample size is 100. Subtract 4.7 and 4.9. Z-score of that, I want to be less than that, so I do keep the area to the left of my Z-score there. Again, you're again looking in here, all right? 5.05 minus 4.9. I want to be greater than that, so I subtract this area to the left of my Z-score from 1. And lastly, let's take a look. 200 values, that's your sample size. Standard deviation is given. Population mean of 514, so in between 500 and 528. Notice they're both 14 away from average, so I will get opposite Z-scores. All right, and I subtract both of those areas to the left of those Z-scores to get 9312. What's the probability that my sample means greater than 550? That is a huge Z-score. The last thing you see, folks, the last one you see on the Z-table is 9998. So if you always want to use that, or if it's quite off the Z-table at 4.67, you can call it 9999, I don't care. You subtract it from 1, so basically a very little chance of that happening. When a pair of fair dice are rolled, what is the probability that the sum is 4 or 5 given the sum is less than 8? That's the probability we're looking at if x is the sum. So look at all these sums that are less than 8. So 7 and below, there are 21 of them, and 7 of them are a 4 or a 5. That is 1/3. And some more conditional probability questions. Did a really good job on our test with these. Given that a person is a smoker, so we're looking here, what is the probability they don't have a college degree? That's the numerator, that's the denominator. We have our answer. Given that a person is not a smoker, that is our denominator, what is the probability they have a college degree? That is our numerator. And we get our answer. Simply, what is the probability someone has a college degree in the sample? So that divided by my whole sample. All right, 403. Given that a person does not have a college degree, so no college degree is now the denominator, 363. What is the probability? I'm sorry, no college degree is 537. That is the denominator. What is the probability they have no college degree? 428 is the numerator. And then given that a person has a college degree, that's 363. What is the probability they smoke? That is 29. All right. You're going to spin a spinner, labeled 1 through 4, so your probability of success is getting a 1, or your success is getting a 1. The probability you're successful is 1 out of 4, 0.25. And you want to find the chance of you winning in 3 or fewer spins, not coin tosses. It has finally been fixed on your final. All right. Probability of you winning on the first one is 0.25. Then you could lose, then win. Then you can lose, win. Add them up. Just over 50%. Single urn contains 2 red, 3 green, 7 orange balls. 3 of them chosen at random without replacements. Take one out, doesn't go back in. All right. Find the probability that none of them are orange. So 5 are beginning, 7 of them are orange. 5 to start with, then 4, then 3. Multiply that together. At least 1 is green, so if one of them is green, that's 1 minus the probability they get no greens. It's only 3 greens, so the chance is relatively high. 32% chance of making a shot at a certain carnival game. You win if you make a shot in 4 attempts. What's the probability that you win in 4 or fewer attempts? All right, you could win, you could lose, win, you could lose, win. Finally, you could miss 3 straight and then win. Add them all up, almost an 80% chance that will happen. On the next one, folks. What is this? 60% of the units come from A, 25 come from B, 15 come from C. 3% of the A's are defective, 4 from B are defective, and 5% from C are defective. So probability it's from A times probability it's defective from A plus probability it's from B times the probability it's defective from B plus the probability it's from C times the probability it's defective from C. Add them all up. Low chance there. What is the probability that something's working? So probability of fine is 1 minus the probability it's defective. Given that a randomly selected unit is defective, so 0355 to the denominator, what's the probability it came from C? It is this product right here. All right. Given that a randomly selected unit is working fine, so 9645 is the denominator, what's the probability it came from A? Chance it came from A is 0.76. If 3% are defective, 97% are working fine. There's your answer. All right. Next one. The independence question. A is the event an even number. You roll a die twice. A is the event an even number shows up on the first one. That's 1/2. B is the event that the sum of the two rolls is 8. That can happen by the following 5. 5 out of 36. I know it's a weird number, but that's what it is. So you need to show that the probability of A and B is equal to the probability of A times the probability of B, or that it isn't. You have to show me that. And you have to show me what the outcomes of A and B both happening are. So A is rolling an even number on the first roll, and B is getting a sum of 8. And that happens with those 3. 3 out of 36 is 1/12. Well, folks, 1/12 does not equal 1/2 times 5 over 36. So they are not independent. No. Let A be the event that an even number comes up on the first row. Let B be the event that the sum of the two rows is even. All right. 1/2 and 1/2 for both those probabilities of A and B. So I want to find the probability of A and B both happening. That means I roll an even number on my first roll, and the sum is also even, so I have to go even in that case. Well, that's 9 out of 36, 1/4 of them, and it just so happens that 1/4 is equal to the probability of both those happening, so yes, they are independent. The baseball player has a batting average of 364, and he's going to get 5 at-bats. We got to change this. First off, I'll change the exponent in a second. His probability of getting a hit is 0.364. So his probability of getting out is 0.636. If I want to find the probability of him getting at least 1 hit, I need to find the probability of 0 hits and subtract that from 1. Again, 5 at-bats, folks. It's going to make that denominator 5. This does not count as a boo-boo because I found it. All right. I'm getting 1041 right here. So that should make that 0.8959 is your actual answer, 8959. All right. Folks, this next one is relatively easy. Okay. Expect just over 50% of the vote. Here we have some Venn diagrams. Easy questions. Notice, folks, it is a rectangle to you out there. Outside is the neither case. Yes, you need that, or you're not getting all right. 37% chance to get into both. Find the probability of just getting to WashU. Take that 0.56 minus 0.37. Find the probability of just getting into Stanford. Take that 0.63 minus 0.37. All right, what's the probability of getting into at least one? That is this, plus this, plus this, or 1 minus the probability you get into none of them. What's the probability you only get into WashU? That 0.19. What's the probability of only getting into Stanford? That 0.26. All right. Next one, the Venn diagram with 3 sets. Okay, the 1-1 needs to go in the middle here. 18 for A and C. 16 for A and B, and 0.24 for B and C. Then, to figure out the probability of only getting into A, you add this, 0.16, 0.11, 0.18, and subtract it from 0.50. Same thing with probability of B. Only B, take this, plus this, plus this, and subtract it from 0.55. Probability of only C, take this, plus this, subtract it from 0.57. Add them all together and subtract from 1, an 18% chance. They all say no to you. What's the probability only Dartmouth, which is C, accepts you? What's the probability that you get into at least 2 of the 3? That would be this, plus this, plus this, plus this. All 4 of those. What's the probability you get at least 1? So you could either sum everything within the actual circles there, or do 1 minus the neither part. And folks, another Venn diagram. 197. Underclassmen math majors. If 103 took both, you take 122 minus 103, get 19, only took Calc 1. Then you take 166 minus 103, 63, only took Calc 2. 12 of them took neither, so what are they doing? What's the probability they only took Calc 1? 63 divided by 197. Alright. What's the probability that they took neither of them? That would be 12 divided by 197. And the probability they only took Calc 1, 19 divided by 197. Okay? Probability, folks, some of you on your test just put like 19 or 12. No, you got to divide it by 197. Probability is always a number between 0 and 1. And on our last page, folks, here it is. 76% free throw shooter. You're going to attempt 3 free throws. Probability to make at least 1 is 1 minus the probability. You miss them all. 24% chance of missing missing 1. Raise it to the third power. Do 1 minus that. Basically, 99% chance you make at least 1. What's the probability you make 2 of the 3? You can make, miss. Make, miss, or make, miss, make, and then miss, make. Well, anyway, notice you're going to do 0.76 squared times 0.24, so that's 3 of those. 0.416. What's the probability to make all 3? So it's just 0.76 raised to the third power. Flip a coin 3 times. What's the sample space? 2 to the third is 8 different outcomes. Could have 3 heads. There's a few different options for 2 heads, a few different options for 2 tails, and 1 option for 3 tails. And lastly, you roll 2 dice. State the probability of rolling at least an 8. At least an 8. That's all of them right there. That is 15 of the 36, which is 5 over 12.